No, he's just in, I think.
No, no, he was
They
up
have a
top.
death trooper. There's a death trooper.
Oh,
There's a death
and
trooper.
now he's really annoying the shit out of me. So now I'm gonna kill him again.
I'm back to
I got Vader's the ship. Let's go. Got her.
Oh, you finished her?
I got her with the
Yeah, they have a-
torpedoes. Welcome back to a rapid introduction to C. Today I'm going to talk about types in C, the basic types you're gonna come across. So I just wanted to preface the video really quick and talk about how types kind of work in C. Basically, everything in C is a number, and the differences between each type. So there's the size of the type, like in bits. Like, for example, we'll talk about how an integer has more bits than a character. And another difference between types is the signedness. So some types are unsigned, which means they can't have negative numbers, and some types are signed, which means they can have negative numbers. There's also floating point values, which, to be honest, aren't really used. Like, I never used a floating point value at all throughout CS230. And everything's a number. Everything's a number. Everything is a number. Everything is a number. Everything is a number. Everything's a number. Everything's a number. Here I have just types.c. I'm just gonna write a main. So the most basic types gonna be int and char. So if I were like int x and char c. So what do I mean when I tell the computer to create an int? Well, an int by default is assigned 32-bit integer. So this means assigned 32-bit integer. When I say 32-bit, I mean it's 32 ones and zeros. So like 1 0 blah 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 blah. 32 of those. 32 ones and zeros. And that's how it's gonna store this variable x. When I say char c, it's actually kind of like an unsigned 8-bit integer. That's kind of what it is. And so if you think about 32-bit integers and 8-bit integers, so the range of this one, since it's signed, it'll be -2 to the 30 to the 31, all the way up to 2 to the 31 minus 1 will be the range of integers this x variable can be. And then this one's going to be 0 to 255. There's also other types of these integer variables. There's going to be short, long, float is not an integer, it's floating point, and double. So these are like floating point types. So these are different. You guys should know this. They have decimal points built into them, so you can have like 2.5. So floatf equals 2.5 would be a thing. So this is how you'd write that, and double d equals 2.5 like that. So short. So what about short, long, and long? So and on an arbitrary machine in C, we just know short has less bits than int has, or less than or the same amount of bits as int, and that has less than or the same amount of bits as long, and that has less than or the same amount of bits as long. By default, these are all assigned. If I take like some arbitrary integer type, I'll just call it int here, and I write unsigned before it, it becomes an unsigned int. You might be asking, how do you do a boolean variable in C. From experience in Java, you might be like, oh, a boolean variable, true or false, true or false. So you do like bool b equals true, and bool b2 equals false. If I save that, what does it say? Oh, bool is undefined. True is undefined. So for booleans in C, what you actually do is you store it as like an integer type or just any type. And if it's equal to 0, that means it's false. And if it's not equal to 0, that means it's true. So if I have like int x equals 1 up here and do if x. Okay. So if x is 1, that means it's like true because it's not 0. But if x is 0, it's like false. So it'll enter the else. So if I just compile this real quick. We did it because it said if x, and then x is non-zero, so it entered this. But if x was 0, it would go into the else because then x is kind of like false. So basically 0 is false, everything else true. So if I just compile this and run it, we did not do it. Perfect. There are two more basic types you're going to need to know that are used throughout the standard libraries. So there's size t, so that's size underscore t, and that's like describing sizes of things in bytes. So like size t size, and in this case it's just like an unsigned integer type with range from 0 to size max. And then there's also s size t. So this is just assigned size t. So it's got range from size min, or s size min rather, to s size max. And these are defined in standard libraries, but you don't really use the bounds that much. You really just use the types. There's a really important function when it comes to types, and that is size of. So if you want to know the size of a type, you can use size of. So if I use size of int, this will be 4. Size of char, this will be 1. And you'll be like, what does it even mean? So size of returns the size of a variable or a type in bytes. So when I say int is 4 bytes, 32 bits is 4 bytes. So size of int will of course return 4, and this is kind of the same as writing size of x, because x is an int. And the compiler knows that, so it's going to return 4. So I can really quickly write a program to show that these are 4 and 1 respectively. So I just really quickly wrote this program to write out what these sizes are. LU just means a long unsigned integer. So this will print out these two long unsigned integers, size of x, which is an int, so that should be 4, and size of char, which is a char, so that should be 1 byte. So let's compile this. gcc types.c and then /a.out. Size of int 4, size of char 1. There are a few other things with size of that we'll go over in the next video, but for right now, that's all you need. One last thing about types is you can define your own types, and defining your own types uses the typedef operator. So if I wanted to define like some type, I wanted to like rename some type, I could rename long as like my ll, like for my long. And the way the scopes work with this is it just like follows normal scoping rules. So if I like put this in its own scope, oops, like this, and then I try to use my LL outside of this, it should not work. So if I just try and compile this, it says unknown type name my LL, but I could use my LL in here. Z equals 6. Compile it. There's no error at this line. So it follows like normal scoping rules, and you do need a semicolon after it because of that. But otherwise, it kind of just replaces, like this is how they define size T and S size T. It just replaces size T with whatever type you want. Like they'd probably use unsigned long. So they probably just there's probably literally a line that just says typedef unsigned long size T or something like that. So that's how you define your own types, and that will also be more useful in the next couple videos. But for now, that's all we need to know. And I believe that's it for this video. So thanks for watching. Come by to the next video, which will be extremely important on pointers. And pointers are hard. So let's go. Wait. We win these, right?
Yeah.
Where did
there's
Dooku go? Did we kill Dookie?
He's next to me.
No.
Oh shit, he's not on the
I
map. Wait,
headshot
is that
him.
Dookie? Yeah, you
You're
got him, you
stunning
got him, you
too.
got him.
That was it.
Oh, you got him.
Shit.
You got him, you got him.
What?
Not on the
He's next to me. Oh shit.